हेलो नमस्कार टू द ऑल केमिस्ट्री लवर्स एंड डॉक्टर्स एंड इंजीनियर्स ऑफ द नियर फ्यूचर। मैं विजय कुमार सोनी आपका वेलकम करता हूं इन केमिस्ट्री वाला चैनल रिगार्डिंग टू द केमिस्ट्री। पर्टिकुलर डे बाय डे हम वीडियोस शेयर करते जा रहे हैं आपके साथ में रिगार्डिंग टू द चैप्टर्स एंड ईच एंड एवरी टॉपिक इज कंसर्न बाय मी। It will be for class 11, 12th and NEET and IIT also, and after just 15 we'll go with the live streaming also on YouTube channel. इसी सीक्वेंस में पर्टिकुलर प्रीवियस वीडियो तक बात हुई हमारी रिगार्डिंग टू जस्ट योर CFT मीन्स व्हाट इज द मीनिंग ऑफ क्रिस्टल फील्ड थ्योरी, मीन्स बेसिक कंसेप्ट ऑफ द क्रिस्टल फील्ड थ्योरी। किसने प्रपोज की? जस्ट यू कैन से वॉन ब्लैक एंड बेदे। अकॉर्डिंग टू दिस थ्योरी ईच एंड एवरी कॉम्प्लेक्स कंपाउंड इज अज्यूम्ड एज अ आयनिक कंपाउंड। आयनिक कंपाउंड के फॉर्म में इसको अज्यूम किया गया। सो व्हाट विल बी रिगार्डिंग टू जस्ट ऑक्टाहेड्रल कॉम्प्लेक्सेस। So first of all we can say that all the complex compound are assumed as just you can say ionic compound की फॉर्म में उनको assume किया गया, where metal atom is your as a cation and ligands as a anion, L minus, and minus, two of the ligand above the plane and below the plane regarding to just your octahedral geometry. Here is the ligand as a negatively charged. We have discussed whenever these ligands becomes closer to the central metal atom for the bond formation, then it will be force of attraction between them because of metal atom is positively charged, ligands are the negatively charged. But between the ligand and electrons of the central metal atom, it will be repulsion due to having same charge because electron exists negative charge and ligand also exists negative charge. So it will be repulsion. So due to repulsion and attraction, these are the 5 degenerate orbitals. 5 degenerate orbitals as a you can say dxy, this is the dxy, this is the dyz, this is the dxz, this is the dx square minus y square, and this is the dz square. These are the 5 degenerate orbitals. Degenerate means having same energy, like just you can say p orbital के लिए regarding बात करें तो px, py, pz, these all 3 are as a degenerate orbitals. Similar to it, f orbital also exists the 7 degenerate orbitals. So regarding to p, d, it will be just 5 degenerate orbitals, where dxy, this is the x and y axis, this is your yz, y and z axis, this is xz, x and z axis, this is your x square minus y square, so x and y square, this will be your dz square, this is the z axis. What will be? Regarding to dxy, just lobes will be between the axis x and y. The yz lobes will be between the axis y and z, like this. The xz or zx you can say, then lobes will be between the x and z axis, like this. And as we all know, just the orbitals are just double shape. These are the dumbbell shape. This is the shape of the orbitals. The orbitals double shape. If we go with the dx square minus y square, then lobes will be along the axis, like this, along the axis, and for the dz square it will be single dumbbell, like this, in dz square. If we go with the major difference between these 5 orbitals, then in these three orbitals lobes lies between the axis, while these 2 axes are along the axis. So in these 2 orbitals, due to having the lobes along the axis, it will be force of attraction and repulsion between just metal atom and ligand and electron. These 5 d orbitals repels each other. Due to repulsion, these 5 d orbitals splits into 2 parts, like this. These are the 2 parts. One of the having less energy than the average energy, that is also called as barycenter, and one of the set exists high energy. If we'll go with the 5 degenerate orbitals, then these are as follows. This is the d orbitals, degenerate orbitals, we can say as a dxy, dyz, dxz, dx square minus y square, and dz square. These 5 d orbitals split into 2 parts. These 3 orbitals feel less repulsion because their lobes are between the axes. So these are the dxy, dyz, this is your dxz, these are the dx square minus y square, and this is the dz square. Feels more repulsion. These are known as AG set of orbitals. And these are known as T2Z set of orbitals. The energy gap, this is called as barycenter. Barycenter, mid of the energy. If we go with the just total difference of energy, it is denoted by del O, where del is your crystal field splitting energy, which we have discussed in previous video, and O means octahedral. O means octahedral. If there is del T, then it will be tetrahedral. We will discuss later regarding the tetrahedral. So this is the del O. It is also denoted by 10 dq. If we go with the just here barycenter to AG orbital, it is denoted by just, you can say, 3/5 of del O. It is denoted by just, you can say, minus, this is the plus 6, this is the minus 4, there is 2 orbital, so 2/5 of del O, minus 2/5 of del O. If we'll go with the plus 3/5 of del O, then it is also denoted by just your plus 6 as a plus 0.6 as a del O, and this will be as a minus 0.4 of del O. So this was about the just crystal field splitting theory. I'm again repeating, according to this theory, when our ligand becomes closer to the just metal atom, then it will force of attraction between ligand and central metal atom, force of repulsion between ligand and electron of the central metal atom, which will be filled over here. Then these are the 5 degenerate orbitals. These fields repulsion and attraction. Due to repulsion and attraction, these 5 orbitals splits into 2 parts. One of the having 3 orbitals having less energy than the barycenter. Those are known as T2G set of orbital. Another having the more energy than the barycenter, denoted by AG set of the orbital. T2G set of the orbital as a just dxy, dyz, dxz, and if you'll go with the just AG set of orbital, then they are dx square minus y square and dz square. This splitting also affected by just the nature of the ligand. If we'll go with the ligand, if we'll arrange the ligand in increasing order of the just donation capacity to donate the lone pair of electron, means electron donate करने की tendency के base पे अगर उसको ascending order में arrange करें, then it will formation of a series that is called as spectrochemical series. So what is that? If we'll arrange the ligands, this is the figure number 6, so this is the figure number 2, figure 2nd, figure 1st, and this is the figure 3rd. Figure 3rd. If we'll go with the just spectrochemical series, if we'll arrange the ligand in ascending or descending order of the tendency to donate electron, then it will formation of the spectrochemical series. Spectrochemical series. Listen me carefully. मीन्स ये स्प्लिटिंग पर्टिकुलर उस रिपल्शन और अट्रैक्शन के साथ साथ लिगेंड की नेचर से भी इफेक्ट होती है. वो कैसे? उन लिगेंड्स को अगर हमने असेंडिंग ऑर्डर में इलेक्ट्रॉन डोनेट करने की टेंडेंसी के बेस में अगर अरेंज किया, देन इट विल फॉर्मेशन ऑफ द स्पेक्ट्रोकेमिकल सीरीज. इफ विल गो विद द स्पेक्ट्रोकेमिकल सीरीज, देन एज अ लिगेंड हियर विल I minus, This is the Br minus, where I is your iodo, Br minus is a bromido, we can say. Next is your S2 minus. S2 minus is called as sulfido. S2 minus is called as sulfido. If we'll go with the further, then that is the HCl minus. This is called as thiocyanato. If we'll go with the further, then this is the Cl minus, chlorido. If we'll go with the further, then that is the F minus. It is called as fluorido. Again, I am repeating. This is the iodo, bromido, sulfido, thiocyanato, this chlorido, and this is the fluorido. If we'll go with the further, then this is the OH minus. This is called as hydroxo. After then, regarding to just hydroxo, we'll take just C2O4. This is called as oxalato. Again, iodo, bromido, because it is too important, sulfido, thiocyanato, chlorido, fluorido. This is your hydroxo, this is your oxalato. Now, the next is your O2 minus. O2 minus, we have discussed about the ligand as a negatively charged monodentate ligand. That is your just your oxo. If you go with the complex compound. Next is your H2O. Further is your, we can take NS3. NS3 is called as just your monodentate ligand, but before NS3 we can take another also, that is your NCS minus. This is also called as amphidentate ligand of HCl, isothiocyanato. Further we can take just your NS3. This is the NS3 amine. So this is the isothiocyanato and this is your amine. So further we can take just En. Further is your NO2 minus. En is your ethane 1,2-diamine. It's a bidentate ligand. And NO2 minus is your just nitro. If we'll go with the further, then that is the Cn minus. And further we'll take last CO, just carbonyl. This is the ascending order on the basis of the just to donate the lone pair of electron. If we'll go with the entire series, then it is called as spectrochemical series. This is the -2 spectrochemical series. This is the spectrochemical series. And if you go with the nature of ligand, then till then S2O. Till then S2O, these are known as weak ligand, as a weak ligand. Weak ligand. And if you go after S2O, then they are known as a strong ligand. So it will also the effect of spectrochemical series over the splitting of the d orbitals. Now, after the discussion of the CFT in octahedral complexes, now we'll go with the just effectant factors, means particular del O को कौन फैक्टर इन्फ्लुएंस करते हैं. नो डाउट अभी जस्ट बताया del O को स्ट्रेंथ ऑफ लिगेंड भी इफेक्ट करती है, दैट इज along with the spectrochemical series. Now we'll go with the just your important part. What is that? Listen me carefully. This is the coupling energy. Coupling energy. This is, you can say, effectant factors as a, this is your effectant factor. If we'll go with the effectant factor of del O, then it is one of the factor that is called as pairing energy. Pairing, or you can say coupling energy. Coupling energy. It is denoted by just either you can denote it pi or p also. It affects to the just your value of crystal field splitting energy of octahedral complexes, means del O. How? Suppose there is, just we'll take example, if del O is greater than pi or p, and another case is your del O is less than pi or p. This is the pi or p. Del O is greater than the pi or p, then it will be formation of low spin complex. Low spin complex. Now the time to discuss the what is the meaning of low spin complex. And this is your high spin complex. Here will formation of high spin complex. Now the time to discuss when it will be less value of the pi or p. Then you will say if there is strong ligand field, and if there is weak ligand field, then it will less value of del O than the pi or p. For this we'll go with the example. This is one of the example Fe Cn whole 6 4 minus. This is another example Fe H2O whole 6. This is the 2 plus. This is called as hexacyanidophenate second. This is called as hexa-aqua iron second iron. In both compound, in both complex, Fe changes in Fe plus 2. So now the time to discuss about the CFT. CFT for this complex, you can see through the diagram. This is the diagram T2G orbital. This is the EG set of orbital, EG and T2G. This is the energy difference as a del O. If you will go with this compound, then diagram will be as follows. This is the EG set of orbital. This is the T2G set of orbital, and you can see T2G set of orbital. This is the del O as a octahedral. You can see here del O is larger, so you can say del O is greater than pi or p. Here is del O is less than pi or p. Less than, so it will formation of the high spin complex, and for the low spin complex it will be del O greater than pi or p. If we'll go with the electronic configuration of the Fe, then Fe is your, you can say, this is the organ 3d6, and this is the 4s2. Whenever it will change in Fe plus 2, then it will your organ 3d6 and 4s0. So now the filling of just electrons. This is in the presence of strong ligand field. We can say strong ligand field. Listen me carefully. This is the for the strong ligand field, and this is for the weak ligand field. Weak ligand field. This is the weak ligand field. So if we go with the filling of electron, then how we can fill the electron? Here is the just 3d6, s is 0. So 1, 2, 3, fourth electron will be in the lower orbital because of energy gap is too larger. So fourth electron cannot migrate over here. So here will formation of, according to this low spin complex, because spinning of electron in the lower orbital, so low spin complex. And this is the high spin complex. How? 1, 2, 3, fourth electron will be in the higher d orbital, and 5, and this will be your 6. So this is the high spin complex. This is the high spin complex. So this was about the just dependence, or you can say factors of the del O. Now we can calculate the value of crystal field splitting energy for the octahedral complexes. This is the CFSE. What is the meaning of CFSE? Crystal field splitting energy, or it can be denoted by del O. Del O. It will be a question in competition exam regarding to NEET and IIT. What is that? We can take the formula. This is the minus 0.4. This is the minus 0.4 x plus 0.6 y, and this is the del O. You can understand me? What is that? If we go with the just the calculation of the energy, then we can calculate by as follows. This is your minus 0.4x and plus 0.6y as a del O. What is the meaning of x and y? Just you can say x, total electron of T2z orbital, and this is the Y is your total electron of EZ orbital. EZ orbital. Listen me carefully. If we'll go with this configuration, then for this CFSE, crystal field splitting energy, here is T2z electrons are in the 6 electron. So the formula will be your minus 0. This is the 4 into 6 electron. Y electron means electrons are not present in just EZ orbital. So this will be 0. So total value will be as follows. This is the minus 6 4s are 24, 2.4 of del O. And if we'll go with this complex, then we can calculate the crystal field splitting energy. This is the formula, that is the CFSE, crystal field splitting energy. Here is the minus 0.4. So this is the minus 0.4. X key value just regarding to X as a 2 and 2 4 electron. So this is the 4 plus 0.6. This is the EZ orbital, 2 electron. So multiply by the 2. This is the del O. So the value will be, this is the 0.16 and this is the plus 0.12. So of del O. So the difference is your minus your 0.4 of del O. This was about the calculation of crystal field splitting energy. So we'll meet in the next video. Till then, जय हिंद जय भारत एंड आपका यूं ही मेरे साथ अट्रैक्शन बना रहे, विश्वास बना रहे. Definitely I'll give you a lot of matter and a lot of topic regarding to the chemistry. Thank you so much.